Copper is a chemical element with the symbol Cu and atomic number 29. It is a soft, malleable, and ductile metal with very high thermal and electrical conductivity. A freshly exposed surface of pure copper has a pinkish-orange color. Copper is used as a conductor of heat and electricity, as a building material, and as a constituent of various metal alloys, such as sterling silver used in jewelry, cupronickel used to make marine hardware and coins, and constantan used in strain gauges and thermocouples for temperature measurement. Copper is one of the few metals that can occur in nature in a directly usable metallic form. This led to very early human use in several regions. From c. 8000 BC. Thousands of years later, it was the first metal to be smelted from sulfide ores. c. 5000 BC. The first metal to be cast into a shape in a mold. c. 4000 BC. And the first metal to be purposely alloyed with another metal, tin, to create bronze. c. 3500 BC. In the Roman era, copper was mined principally on Cyprus. The origin of the name of the metal, from Acaciopryum and copper, were derived from this. The later spelling first used around 1530. Commonly encountered compounds are copper salts, which often impart blue or green colors to such minerals as azurite, malachite, and turquoise, and have been used widely and historically as pigments. Copper used in buildings, usually for roofing, oxidizes to form a green verdigris. Copper is sometimes used in decorative art, both in its elemental metal form and in compounds as pigments. Copper compounds are used as bacteriostatic agents, fungicides, and wood preservatives. Copper is essential to all living organisms as a trace dietary mineral because it is a key constituent of the respiratory enzyme complex cytochrome C oxidase. In mollusks and crustaceans, copper is a constituent of the blood pigment hemocyanin, replaced by the iron-complexed hemoglobin in fish and other vertebrates. In humans, copper is found mainly in the liver, muscle, and bone. The adult body contains between 1.4 and 2.1 milligrams of copper per kilogram of body weight. Copper, silver, and gold are in group 11 of the periodic table. These three metals have one s orbital electron on top of a filled d electron shell and are characterized by high ductility and electrical and thermal conductivity. The filled d shells in these elements contribute little to interatomic interactions, which are dominated by the s electrons through metallic bonds. Unlike metals with incomplete d shells, metallic bonds in copper are lacking a covalent character and are relatively weak. This observation explains the low hardness and high ductility of single crystals of copper. At the macroscopic scale, introduction of extended defects to the crystal lattice, such as grain boundaries, hinders flow of the material under applied stress, thereby increasing its hardness. For this reason, copper is usually supplied in a fine-grained polycrystalline form, which has greater strength than monocrystalline forms. The softness of copper partly explains its high electrical conductivity and high thermal conductivity, second highest among pure metals at room temperature. This is because the resistivity to electron transport in metals at room temperature originates primarily from scattering of electrons on thermal vibrations of the lattice, which are relatively weak in a soft metal. The maximum permissible current density of copper in open air is approximately 3.1 times 106 A per square meter of cross-sectional area, above which it begins to heat excessively. Copper is one of a few metallic elements with a natural color other than gray or silver. Pure copper is orange-red and acquires a reddish tarnish when exposed to air. The characteristic color of copper results from the electronic transitions between the filled 3D and half-empty Fors atomic shells. The energy difference between these shells corresponds to orange light. As with other metals, if copper is put in contact with another metal, galvanic corrosion will occur. Copper does not react with water, but it does slowly react with atmospheric oxygen to form a layer of brown-black copper oxide which, unlike the rust that forms on iron in moist air, protects the underlying metal from further corrosion. A green layer of verdigris can often be seen on old copper structures, such as the roofing of many older buildings in the Statue of Liberty. Copper tarnishes when exposed to some sulfur compounds, with which it reacts to form various copper sulfides. There are 29 isotopes of copper. 63 Cu and 65 Cu are stable, with 63 Cu comprising approximately 69% of naturally occurring copper. Both have a spin of 3 halves. The other isotopes are radioactive, with the most stable being 67 Cu with a half-life of 61.83 hours. 7 metastable isotopes have been characterized. 68 MCU as the longest lived with a half-life of 3.8 minutes. Isotopes with a mass number above 64 decay by beta minus, whereas those with a mass number below 64 decay by beta plus. 64 Cu, which has